All right, so today we are continuing to do centers of triangles. So our objective is that the student will identify and draw mid-segments and apply mid-segment properties, because we're going to have a theorem on it today, as you see on your notes. We went over the test, so you should know your grade by now, right? And if your grade's not where you want it to be, come to tutoring and do what you need to do. If you need to retake a quiz or a test, you got to come to tutoring, please. All right? And there should be no headphones in our ears, but we know that. We're just being a little silly today, right? Please. So, other things you got to know. Yesterday, we were working on the backside of the assignment we got on Monday, so make sure you have worked on that. Turn that in. If you haven't finished it, you might have some time to finish that today. But you got to use your notes from Monday and Tuesday and Wednesday to finish the assignment I gave you Monday. But today, on the notes sheet that you're filling in, the 5th line, right? So, the 5th line, not the 3rd line, not the 2nd, not the 4th, but the 5th section, you should have written down mid-segment. Mid-segment of a triangle is a segment that joins the midpoints of two sides of a triangle. It is parallel to a side of the triangle, and its length is half the length of that side. That's important. We're going to talk about that in a second. Okay? And over here, no point of concurrency. This is not a center, but it uses midpoints to make an inner triangle called a mid-segment triangle. Okay? So, also, can you do this? Who knows? All right. That's a mid-segment sign. Now let's talk about the notes. So again, a mid-segment of a triangle, looks like off to the right here, is a segment that joins the midpoints of two sides. So if I was going to draw over it to emphasize, it would be from here is a midpoint. Now how do I know this is a midpoint right here? What are the little marks you see? Tick and tick. So again, we know it is a midpoint if we see tick marks to the left and to the right of the midpoint. So for example, on QR, we know that Y is a midpoint because I have 3 tick marks on each side. I know Z is a midpoint because it's got 2 tick marks on each side. Okay, so everyone knows how to tell if it's a midpoint if it's got the tick marks to the left and the right. Okay. Now, if I connect a midpoint to a midpoint, that's called a mid-segment. Midpoint to midpoint, mid-segment. Okay? So every triangle has 3 mid-segments, which makes a, underline this, mid-segment triangle. There's a name for that inner triangle. It's called a mid-segment triangle. And like I pointed out earlier, if you know your video game references, it looks like a Triforce. All right, so look down here, triangle mid-segment theorem. This says a mid-segment of a triangle is parallel to the side of the triangle, and its length is half the length of that side. Okay, so if you're looking at this picture off to the right here, DE is half of AC. So you know if you connect 2 midpoints, that's going to be half of the side that it's parallel to. Okay? So, how does that work? So if you're looking at practice problem 1, I'll show you how this works. Find UW and the measure of angle SVU. Dun, dun. All right, so number 1, finding UW from here to here. We just said that this is a mid-segment connecting 2 midpoints, and it's going to be half of the parallel side. Now, how long is this parallel side over here? 7.4. So how do I find the mid-segment? We find half of 7.4. Okay, so UW equals 1/2 times 7.4. Now, someone said you could just divide by 2. That's correct. you could just divide by 2. Multiplying by 1/2, dividing by 2, same thing. Okay? So half of 7.4. What is half of 7.4? 3.7. Yes. All right. So right here, UW is 3.7. And I want you to notice, on this parallel side, each half is also going to be 3.7. Because doesn't two 3.7s make 7.4? So whenever you're doing mid-segments, you're going to have this and half. All 3 of those little segments are going to be equal. But altogether, this one's double the mid-segment. Okay? And then it says, find the angle of SVU. Okay, so we'll do this one in another color. SVU is this angle right here. Okay? The only angle I know is this angle right here is 41. Now, remember, part of the properties is that we know that they are, up here, parallel, right? So this is parallel to this. Now, this is going to make us think back in time, okay? When we talked about transversals and alternate interior and alternate exterior and corresponding and same side interior and same side exterior. Y'all remember all that stuff perfectly? Yes, you do, of course. So, but just to refresh some of y'all, just in case you don't, this and this are between the parallels on different sides of the transversal, so we call that alternate interior angles. Does anyone remember? Alternate interior, are they congruent or supplementary? Alternate interior, what are they? Congruent or supplementary? They are congruent. The only ones that were supplementary were the S's, same side, supplementary. Okay, so this is easier than it looks. If this is 41, guess what this one's going to be? 41. Okay, so the measure of angle SVU equals 41 degrees. Okay. So again, we're using properties of what we learned before to find the missing angle. Look at number 2. Find the perimeter of the what? Mid-segment triangle. So give me the 3 letters of the mid-segment triangle. So I heard someone say KLM. Does anyone think the mid-segment triangle is GHJ? Okay, so GHJ is the original triangle, but that was correct. The mid-segment triangle is from the midpoint to the midpoint to the midpoint. So it is KLM. All right, so I need to find that perimeter. So, do I know any of the sides of KLM? So one of these numbers is already here. This is 7, right? I just got to figure out the other 2. Cool. So I'm going to do ML. I'm going to do this one in red. How do I find ML if the parallel segment is 12? So what did we say about mid-segments? They are what fraction of the parallel side? 1/2. So just like we did on number 1, if we're going from the big segment to the parallel mid-segment, we just got to divide by 2, or find 1/2 of it. Okay? So again, from G to H is 12, so M to L is 6. Is everyone seeing why I did that? Parallel side to mid-segment is 1/2. Okay? Now what else is missing? Well, the third side of that triangle, that mid-segment triangle, KM, that's missing. Now I'm going to look over here, the parallel segment. 1/2 of the parallel segment is 4. What's the other half going to be? 4. What's the whole thing going to be? Add them up. 8. So again, they're not always giving you the whole segment. If they give you half the segment, you can figure out the whole segment, double it, right? So guess what km is going to be if the parallel side is 8? Half of that, which is 4. Okay? And it seems and it feels like we're done, but we have one last step. We're looking for the perimeter. So now that I know all 3 sides, what do I do with all 3 sides? Perimeter means add them up. Okay? So the perimeter, I'm going to add, it's going to be 4 plus 6 plus 7 equals 17 is my perimeter of the mid-segment triangle. Okay? So you see how that works? Let's flip it over. On the back, what is the distance across the pond? So give me 2 letters for distance across the pond. From what to what? Across the pond. What 2 letters? From X to Z, right? That's Jay-Z's second cousin, XZ. All right. So across the pond, if I know the mid segment is 39, how do I find the parallel side? This one's kind of working backwards. I'm going to need to multiply it by 2. So instead of dividing by 2 to go from big to small, now I'm going from the small mid-segment to the parallel side. I'm going to have to multiply by 2. So 39 times 2 is 78. Okay? So the distance across the pond from X to Z is 78 meters. Does everyone see how that works? If you know the mid-segment, double it for the parallel side. If you know the parallel side, cut it in half to get the mid-segment. All right, and what if you got some algebra in the problem? So number 4, if DE is 2x and BC is x plus 12, we know that 1/2 of BC equals DE, right? Half of the big one equals the mid-segment. So let's replace BC with x plus 12. Let's replace DE with 2x. And do y'all remember how I get rid of a fraction? To get rid of a fraction, you multiply by the denominator, the number on the bottom. So everything is going to be multiplied by 2 here. 2 times 1/2 cancels them out. So I'm going to bring down x plus 12. And then 2 times 2x is 4x. We do that to clear the fraction. And now x is on both sides. I get rid of the smaller x. So I get 12 equals 4 minus 1 is 3x. Dividing by 3 gives me x equals 4. If x equals 4 and DE is 2x, then I replace x with 4. 2 times 4 is 8. Okay, so again, plug x back in to get the missing side DE, which is 8. Okay? And then on that last one, 5 says triangle ABC has vertices A, B, and C. Write the equation of the mid-segment of this triangle that is parallel to segment BC. So let's plot these points at -5, 6, 1, 2, and then -7, -2. Okay. And then for the mid-segment, I need to find the midpoints parallel to BC. We're just going to plot the midpoints and connect them. So 1, 2, 3, 4, 5, 6. Half of 6 is 3. Go up, put a point. And then 1/2 of that straight up. Okay, Mine looks terrible. But you should be able to connect the midpoints to make your mid-segment for B, the mid-segment BT.